Okay, so let's come up with a game plan for how we can estimate sampling distribution. So what we're going to do is we're going to start with one single sample. For example, 1009 values corresponding to babies in North Carolina. So we just have one sample of size n. So from that sample, we're going to construct a new sample by picking n values, the same number of values from the original sample with replacement, obviously. So if we picked n values without replacement, then we would definitely get back the same exact n values. So I'm gonna take my sample, I'm gonna pick a value, then I'm gonna put that value back in, I'm gonna pick a second value, I'm gonna put that value back in, pick a third value, put it back in, and we're gonna repeat this n times, right? So I wind up with what we're going to call a bootstrap sample that has n values in it. Then we take that bootstrap sample and we calculate some statistic. For example, a mean of that bootstrap sample, or maybe a proportion or a variance. And then we go back and generate a new bootstrap sample, calculate the statistic for that new bootstrap sample, and we keep going on and on and on and on again. And then we can look at the distribution of all of our bootstrap statistics. So it's very similar to what we do with the sampling distribution. Instead of picking a bunch of random samples from the population, we're now picking a bunch of bootstrap resamples from our original sample. So let's take a look at an example here to get a sense of what bootstrap samples might look like before we jump back into the example with the births. So let's say, for example, our original sample, instead of 1009 values, let's just start with a more manageable amount of values. So we're going to start with, let's say our original sample had 4 values. And let's think about each of these possible samples, each of these 5 samples here, and see which of them could be a possible bootstrap resample and which ones not. And you might want to just hit pause here and try and answer this question for yourself, but I'll go through it. So in the first one, we've got these 4 values. The value 3,800 was picked. It gets put back in. We pick a second value, 3,065. We put it back in, and then we pick a third value, 4,010, and then we stopped. And so here the problem is our original sample had 4 values. This bootstrap resample only has 3, so that's a no for this one. Our sample should have the same number of values as our original sample. So 1 only has 3 values, that's no good. And for the same reason, the sample in 3 would be no good because that one has too many values. We should only have 4, that one has 5 values. So 3 and 4 are out because one definite requirement is each bootstrap sample should have the same number of values in it. Okay, so now let's look at 2, 3, and 5. Since they all satisfy that criteria, they all have 4 values in it. So in 2, we've got the value 3,800 4 different times. Could that be a possible bootstrap resample? Absolutely. So that would be a yes for 2 because we're picking with replacement. So I could pick 3,800 first. I put it back in. I could pick it again, put it back in, and I could actually pick the same value 4 times. So that's definitely a possibility. Looking at the third one, we pick a 3,800 first, we put it back in, then we pick 3,065. That's a value, we put it back in, 2,950, and then 4,100. This is actually the same exact sample that we started with. And so it is possible that we could pick a bootstrap resample and get the original sample back. We've got 4 values. Each of those 4 values was in the original sample, so that's possible. And looking at the last one, we've got 4 values. I could pick 3,800. I could pick 3,065. I could pick 2,950, 3,450. Where did that come from? So there's no way that I could have picked it from these values up here. That wasn't one of the original values. That's not in there. So this last one would be a no. So hopefully that gives you some sense about what the Bootstrap resampling process involves. And as we're going to set up simulations to create these Bootstrap resamples, these Bootstrap distributions, it might be good to just think about, well, how many possible Bootstrap resamples can there be? And so if we return to the North Carolina birth weight example, N was 1,009 because we had 1,009 observations. And so for the first value that we pick, we have 1,009 possibilities. Then we put that value back in and we pick another value. And so pick number 2 has 1,009 possibilities as well. And we would keep doing it. And each time we pick a value for our Bootstrap sample, we've got 1,009 possibilities. So basically, what we're getting is a total of 1,009 raised to the power of 1,009. Go ahead, try calculating that in R and see what you get. That's really, really large, and in fact, I think you might blow up R if you try doing that. If you don't trust me, give it a shot. But the point here is that there are tons of Bootstrap resamples that we can generate.